One time I looked at a system, I said, I'm just curious, how many Windows licenses are in this box right now? And he goes, like, counting, 13. I'm like, dude, that's just nuts. The invisible layer between your robot and your results. Nobody talks about it until now. Coming up next on Helical Brew. Welcome, everybody. It's time for another Helical Brew episode. I'm Mike Ouren, and I'm joined with Sura Hadi, co-host as well, and Michael Salmi. Welcome.
Oh, yeah.
Yeah, we're glad to have you with us. Michael is the founder of Cheshire Labs, and we're going to talk with him about schedulers, which is what they're doing over there. And this episode is titled Building the Missing Layer, Open Scheduling, Swarm Automation, and Why Labs Need Control. It's a hot topic in the market, and I can't wait to talk more about it. So just a quick intro to the episode here on Helical Brew. This is going to be part of our Automation on the Wild series that we've actually done a couple of episodes recently on. So welcome back to Automation on the Wild, where we focus on what actually happens once automation hits real labs. Today, we're joined with Michael Salmi, founder of Cheshire Labs and creator of Orca, an open source scheduler born out of years spent integrating and maintaining real automation systems in production environments. Just to give you a little background on Michael's background spans clinical labs, contract labs, biotech R&D, and platform-level automation engineering, including building custom schedulers, writing device drivers, and stitching together liquid handlers. I like that phrase, limbs, and cloud infrastructure. That is just one paragraph, but that you could expand out into multiple pages of skill sets required to do all these things. So welcome, Michael. We can't wait to dive deeper into all that's behind that and all the things that you've done and how you came to the company. We also want to hear how that company name came about. Of course, we're keen on that. And so we'll get into it. We're going to dive deep, but before we get started, let's start with a little icebreaker question. And that is, what was the moment you realized the tooling available to labs wasn't good enough? And you'd probably have to build it yourself.
Yeah, I mean, there's a whole bunch of moments where I kind of ran into things, but I guess one of the simplest is just trying to get metrics off of a system. And this was like a job that I was trying to do at Sura Therapeutics, just trying to build a metrics to find out how many tips are being used and how many plates are going through and how often a device is being used. And for that, you really just need like an integration layer, but then you have to interface with all the devices and everything. You got to write it all out and just trying to get events off of things. That probably wasn't the first time that I realized I need to make custom tools for this, but
he's got so many, it's hard to pick.
Yeah, it was just like the most
there's
simple.
a library of reasons.
Yeah.
Yeah, I'm sure. And I'm sure more will come up as we're talking, right? I mean, at the end of the day, I come into some labs and I always come at it from a robot perspective. That's my background. But, you walk in and you're like, wow, piece of software 1, piece of software 2, piece of software 3, 4, 5, 6. Every single one of them has a totally different behavior. And that's where folks seem to be spending most of their time, is on trying to get stuff out of the devices at the end of the day. So
as soon as you said vWorks, I was like, oh yeah, of course you had to have some sort of like some sort of tool that you needed to invent to get around something.
Yeah, I didn't even invent anything for that. I was just trying to every day I'll just start running it, work on something else, wait for it to mess up.
Oh boy, hackathon time, figure out how to make it work. That software dates back to, the late 90s, right? So it's been around the block.
Yeah, I feel like a lot of software was developed back then, and then it hasn't really. I mean, new software is being developed, but it hasn't really, you're still using vWorks at a lot of places. So it needs that next revolution coming on with things.
Yeah. I think it's hard for them to think about the next revolution when all we do is get frustrated and put some other layer on top of it, right?
Yes, yeah. It's definitely true. I get worried that we just keep on layering on top and not worrying about the software that's kind of underneath things. Like now AI's here. We're kind of trying to force it on top of the other software.
Oh yeah. What if we start building this stuff on toothpicks, effectively boring? Oh no. Wow, you got this great stack above it, but what about this little layer at the bottom? Yeah. I think the PC industry went through that, right? Especially in the 90s and early 2000s, where they had to really strip out a lot of old infrastructure because they just kind of put USB on top of everything. USB drivers were the bane of everyone's existence on a PC because they had no every time you acquired an install. So I feel like we're kind of going through that sometimes in this space where, the underpinnings, no, you really do need to rewrite the entire low level stack for this,
Yeah. I mean, when you're in
Yeah.
the lab working on things like that, it's just like your actual automation stack that you're thinking about. Like, how can I get my work done with everything that's given to me and at hand?
Yeah.
Yeah, definitely.
Yeah.
And trying to integrate with like Windows applications and stuff starts getting difficult. So trying to bring it kind of back to the like standard programming a bit has been useful.
So I think you kind of touched on this already, but let's dive into the first segment, life inside real automation stacks, right? And kind of, that's where we can extract even more stories about, your experiences. But what did automation actually look like day to day at places like Zotis and Tessera for you?
Large methods,
Okay.
like thousands of lines of methods in Venus. I think we had one that was like 8,000 lines in a Venus file, and just trying to, you meet with scientists, they want to make a small change, and it's like, oh man, is first we got to decide if this is really needed. Like, how badly do you want this change? Because it's probably going to break a lot of things if you make this change. And then you got to copy the file. You got to do some weird version control of like 3.6 or something, and then put it in some weird folder somewhere. So just like having better version control for just something like that. But yeah,
I love when people say it's just a small change, these scientists. And meanwhile, the automation engineers like that GIF with the lady looking at like theoretical quantum physics in the sky.
Famous last
What
words.
level am I changing and what guide?
Yeah, because you get so many like if branches through these things of just trying to follow the logic of if this changes, and then there's duplicate variables within it that change one variable up here, but it's not using the same variable down here. Just it's kind of a lot of that, but it's not just Venus.
Yeah. I sometimes wonder if these like architectures and especially liquid handlers, because I've said it before, I equate the liquid handler as the piano of the lab in a way, because, you can make extraordinarily complicated music on a piano with just one person. And you've got two hands, you've got all these keys, and it's like, I feel like, did they anticipate somebody would actually go with this many lines, or something like that? What was their kind of expected sweet spot for the use of the instrument? And because, at the end of the day, it's the customer that pushes the limits, right? And I'm sure they've heard the feedback. Could you optimize this and optimize that? And then you come in and it's like, well, we'll just optimize the whole thing. And so.
Mike has sonatas in his head with liquid handlers.
Yes, it's like Vivaldi, maybe. No,
but I'm glad that you said that, because I think that liquid handlers are the backbone of the lab. They're what's doing most of the transfers, and these schedulers don't have access to like the low level control. It's just kind of, is it Lucas from United Labs?
Yeah, United Labs. Yeah, he's just telling you.
Yeah, he nailed it when he said we're treating it as a black box, and like that's just not acceptable, and it's been accepted for a long time with a lot of things, and I think you need that kind of low level control with these liquid handlers.
Oh my God, Mike, he listens to our podcast.
Yes, it's awesome that you referred to a past episode. We're so stoked right now. So yeah, no, that's super cool. He had a lot of good insight on just the taking customer feedback right at the end of the day. Like all this stuff ties back to what he's trying to do, and it's like leads me into the next questions, like how much time was spent on gluing things together versus running experiments. I mean, I have to imagine it just sort of puts you over the top. Let's start a company, right? But I mean, when you were there, what would you say that the balance was between those two?
I mean, I guess integrating it all together is like getting ready to run the experiment, but like doing most of the time is spent like testing things. The
Okay.
development side of things, and the development side of things is just really frustrating because everybody's doing it. They're doing about the same thing of trying to integrate this all together to get it all to communicate with each other. And so every company I go to, it's the same thing. We got to integrate this all together. But yeah, I think that testing is probably the
Yeah.
largest space of getting ready to
Okay.
run something because it's not really like the development so much as building a workflow or a method. Every lab automation engineer are really excited to get a new protocol. They want to build that development, but then
Yeah.
they get to the testing phase of things and it's just like, man, just you run into this one step, you can't run it over and over again, and you just come like hitting a wall of just like you have the tear down, like the plates are everywhere, you got to refill them and everything, you got to move them back to the big things, and then you run it all through again, it screws up again, you got to pull it all back, and like the 10th time that you're doing all that gets frustrating.
But
Yeah.
testing can be
That makes sense.
alleviated, right, by being prepared. In a sense, our old team, we set up testing protocols. So there's stopping points and different things that you can program in to allow you to test in a manner that doesn't have this big mess or seeing the program end to end finish. But you have to think about that at the outset.
Yeah, exactly. And you know, in Venus now I put like a test flag if I'm testing it, then I'll just I'll run these variables through it because while you're testing, you're changing a bunch of variables too. You get into production, it gets to the very end, and like you forgot to change some variable and everything's screwed
Right.
up.
And you don't
You're
want
all
to
embarrassed about
delete
it.
and mess with your code that way. So it's much better to have those flags.
Yeah.
Gotcha. Yeah, it makes sense. When I was thinking back to my time as an application engineer in robotics, yeah, the having to put everything back to square one after it stopped 30% of the way through. I'm like, okay, reset.
Do you remember back in the day you got like the little squirt bottle and you're trying to like manually fill the 96 ml?
Yes, that still happens. I'll do that.
Fake it.
Get your pipette, 100 microliters.
Well, because you're like, well, this is going to be the final test. And then you're like,
Yeah.
oh, well, one more. I'll just grab that squirt bottle. And then you're just there for the next 8 hours with this thing of
He
like,
knows,
this has to
he
be the
knows.
final one.
Final countdown. So where did the vendor software fall short, when you were working in those environments?
Yeah, I mean, I think touched on that a little bit with like not being able to just kind of run a test. The version control, I feel like really got to me because the liquid handler black boxes, not being able to like just put through changes to a bunch of variables, like at the scheduler level, just turn off all the liquid level detection and everything on the liquid handlers for if you're dry testing and wet testing and things like that. Which I think that a lot of, if we did lab automation a little bit more of like software engineering principles, similar to Solid, of just having like follow those certain principles when building of like small methods and just having the scheduler worry about the logic and doing all that.
Yeah,
And
I
then
think that
also
was the
Sorry, go
biggest
ahead.
change that I encountered in my career is, coming at it from being like a scientist to an automation engineer, you make a lot of headway. And it wasn't until I worked with my last boss who came from a software engineering background that it really elevated my skill set to another level because now we got to use some of those best practices and principles. And you don't realize that those are absolutely necessary for what you're doing and all the frustration you're feeling until you put them into practice and see how they actually better your life day to day.
Yes. Yeah, I think pulling a lot more of it into the scheduler and treating the devices more as almost like printers. Most printers work about the same way, and then you can inject whatever you need to into them.
Yeah, that things where drivers just went away. That was one of those things, right? You just didn't have to deal with drivers anymore. There's like, there's a standard model for it. Okay, finally, after 40 years of things, we have a standard driver set. But that actually brings up a great one. Like, out of all this stack of software, things communicating with other things, which point is the most fragile in the whole stack today?
Yeah, that's hard to say. I guess I would just say the integration point of interface and everything together. Right now, a lot of it has to be deployed like locally, And I think just trying to centralize it a little bit more would make things a little bit easier if you, instead of like duplicating everything across the whole system, like a labware definition on one Hamilton, and just pull that all up into the scheduler and have it inject it down, even teach points and everything like a lab automation depot.
You're also talking about currently the orchestration layer is somewhat disconnected from the process. You're putting it on top. Having a way where that integration is tighter, right? Where you can actually pass this information back and forth would really be helpful.
Yeah, that's how I'm kind of viewing things, especially like labware definitions, changing from system to system. And that goes back to kind of like the dependency injection. You have all these like labware dependencies across different liquid handlers, and they should just live up in the cloud or in the scheduler and just push down. Same with deck layouts and stuff. Should be able to edit that. The whole method, I think, just put it in the scheduler.
Yeah, it's like the media itself is actually standardized. There's this great standard around it, yet the data that's used to work with these different sizes is all stored uniquely and specifically in each piece of software. And you're like repeating the same thing over and over again.
Yeah, you got to jump from computer to computer to do it.
Yeah, how many Windows? I asked a question one time. I looked at a system. I said, "I'm just curious, how many Windows licenses are in this box right now?" And he goes, "Like counting, 13." I'm like, "Dude, that's just nuts." So that's 13 pieces of software that have to be updated. 13 things that can become suddenly incompatible. 13 things. Yeah, IT probably. Yeah, I'm sure IT is quite a healthy department in most of the pharma companies for that reason. I don't know. I'm so used to the world of platform agnostic communications systems where it's like if you have TCP, you can talk to it if you want, and it's like when you get to a more complex device, it's sort of legacy with having local software. It's a tougher question.
But I mean, you're describing basically that right now, because of this disconnection between what you're trying to do and how you're trying to go about it as you move from system to system, computer to computer, the bottleneck between the two is actually not having the scheduler be able to do all this, correct?
Yeah. It's like jumping from system to system, like a little bit of information stored on like the Venus computer. And I just kind of wish that it was all in one spot. Like I just sit at like with Solario, I was working with that. Wish I could just sit there and just be like, oh yeah, that variable's the wrong name or something on the Venus system. And they have, a remote screen, but it should just be in the scheduler and just be able to serialize it all, have it all in Git. That's kind of how I envision things a bit.
Yeah, like plug in my audio interface into my computer. All the parameters for it just show up in this one box in the settings pane. Great. Yeah. If only. Note to vendors. If you could just, well, and that gets into our next segment about schedulers, drivers, and, hidden complexity. I mean, there's, I just got this great device, and all of a sudden everything works great up until boom, and who knows what that point might be. I'm sure it has to do with interfacing very often, but
I think it gets down into the somewhat part of the testing with things and just being able to copy, because when we were working with Solario, we just want to run, you have your production and you want to make some changes or do a test, then you have to copy that whole thing over to like a new method, and you start building it all out over there, or a whole new workflow.
It's true in a lot of software development in general, is the kind of, and this is true in robotics, very much true, is a sort of top-down approach, right? There's a process you go through to go from teaching points to programming, whatnot. And now it's much more open, and you can insert new code, and you can do things kind of on the fly, which I think is kind of what you're getting at. Whereas instead of just starting over every single time, you can have this sort of multitask, multi-threaded robot system where you got air control and one thread and whatever. But I mean, early on when I started in robotics, it's like you did really have to copy and paste the program over here, then start and then create a slight tweak on it, and then do it again. And by the time you were done, you're like, with your testing resulted in having 5-6 different permutations of the same code with a small change in each one. And I think that's kind of what you're getting at. It's like you can't really insert something in the middle. You got to start over.
Yeah, and I think that it's the same way still in lab automation. I think of we're still doing that, and just being able to do a diff to see what's changed between what you were working on over here and then what you're working on over here, and be like, oh, what has been changed over here?
Yeah, it's kind of it's a little bit of a more closed environment. You're not working with like a C# file or something where you could just put it in a
Yeah.
code diff check and say, okay, great. But this is sort of proprietary. It's their storage format, their save file, whatever's saving the method. And, it's hard to can't really dive into it directly, I guess. Yeah.
And there's so many tools in just general software that are kind of built around, like the ecosystem and software engineering is kind of built around to solve a lot of the issues that I've kind of found.
Well, switching gears to device drivers, I mean, what's the reality of writing and maintaining device drivers in today's environment?
AI's made it a good bit easier. You just plug into the PDF, and I know with
no kidding.
Yeah, with precise
you mean
flex.
they can't charge you $14,000 a driver anymore?
Like, I'd be happy to charge that. Just give me the PDF and I will just plug it in. Yeah, I was at doing the precise flex with Brooks, and y'all gave me the PDF, plugged it in, and wrote out like the first one, and it just kept on chomping, just knocked it out pretty quick.
All right, good to hear.
So I don't know how much credit I can really take for like AI on that. I had to do the testing. That took a little while, and make sure.
Part of our AI series, build some drivers.
This episode is now across 2 of our segment series. That's very cool to hear. Hey, look, I mean, that's a powerful tool right there. If you're able to get started and you're basically left with, some tweaks and final testing on a robot driver, that's pretty cool. Because, robots are notoriously there's a lot of variability. There's a lot of, architecting how the robot approaches and departs and figuring out how to make that adjustable and scalable and, in a UI that makes sense for your software. So yeah, very cool to hear that. And why is it that every integration feels custom when vendors say it isn't? Not like this one.
Yes. I mean, everybody's doing a little bit different. They always got some weird plate map.
Weird plate map.
Some of this plate map.
Yeah, because, you're dealing with people in the wet lab that are coming into
Well, they
automation.
plan it like they pipette it with a multi-channel. And I'm like, that's not how the robot... That's not the most efficient for the robot. The robot can do that, but
they start building like a lot of the other stuff around what they've been doing in the wet lab, and then you're like, well, we're thinking about changing this, and they're like, nope, I have this Excel file, I've got this other thing that are dependent on that plate map. But yeah, it just it always depends on. Labs are all doing completely different stuff, and when I build method, always get them or try and get them to change it to like some generic non-custom thing. But then once you start digging down into it, there's like some good reason that it can't change, and it's like, all right.
Yeah, I got you. Well, let's spin it into why you built Orca.
Yes, tell us a little bit about Cheshire Labs and Orca.
Yeah, this is I think this is a good segment before we get into Orca. Like, what's the background on the company name?
Right, and can I get the swag at SLAS so I can wear a t-shirt?
I'll be bringing stickers. They got glow-in-the-dark stickers too, so you can have the cat glowing. But so my niece's name is Alice, and my grandmother's name was Alice. And when my grandma passed, I got her computer, so it was named Alice. And then all my devices after that, I was like, oh, what do I name them? And it was Cheshire for the cat, because it's Alice's friend. And then it just kind of, because I was doing the development there, I was just like, it's Cheshire Labs. And it's kind of about trying to take like a unique view how to fix lab automation. Then it also works out that lab automation just drives you mad when you're trying to get it to do something, and you got to hack into it and think about things a little bit weird. So that's a bit of where the name came from.
Okay.
And you have company tea parties?
No, but that's a good idea.
Not a happy hour tea party.
Well, they can have like
they can have Long Island iced tea.
Yeah, Long Island iced tea. Mike's hard. Oh, that's lemonade.
Hard
lemonade.
Iced
tea one.
Too far.
Yeah, there's an iced tea one. Yeah. Okay. Well, very cool. Very cool. Thank you for sharing that. And so coming back to why you built Orca, what problem was Orca designed to solve that commercial schedulers weren't doing?
So I had the theory of like, oh, I wish that everything was more around that solid principles and everything and could be saved to Git. So I started building it out there so that you could run like a small method and keep the method small, kind of pull the logic out a little bit outside of the method, have like an event bus on there. I guess it's somewhat new on Orca. So just trying to like deploy configurations too for if you're working on doing wet testing versus dry testing or just a simulation, and pushing all those variables down into the drivers that we're running. Originally it was all to drive it off of a YAML file, just like you deploy serverless infrastructure. But I kind of moved away from that because it was a little bit too rigid. But now with AI coming in and things kind of being JSON models again, maybe it could be useful again. So it's kind of in between those a little bit, but mostly Python models again.
Okay.
Running everything.
No, it's a fair thing. You're going to, as you're going through this process, maybe bounce off a couple of standards and a couple of tools that you come across. And, it's the beauty of your scenario is you got agility. You can do what's best for the solution at the end of the day.
And I love that you've got to focus on open source. I really think it matters in lab automation, and we don't really see it a lot. I know at my last company, my team was focused on trying to get some open source code out there. So that's great that you guys have that focus too.
Yeah, with Orca, I guess that was a lot of the focus too. If it fails or if it succeeds, just release it so that it's open source. Because I hadn't really run into any open source schedulers before when I was writing that. Now, I think that there's a couple open source schedulers that have been released, which I've looked into a little bit. But yeah, it's awesome to see that people are writing these and releasing them.
Oh, it's huge. I mean, look, cost is a big deal, especially when you're starting a company, founding a company, right? And you can get started on science without having to just basically blow all your, initial funding on buying stuff, which software can constitute, geez, I mean, $30,000, $40,000. That's just one simple license for, not much.
It would really suck if like a startup's trying to do something, they just need to automate a part and they just can't fund the like schedulers can get expensive. Just run it with this, and now it's compatible with PyLab robot, so they can use whatever drivers that are there. The first time I heard about drivers, we were like, oh, we'll just get this driver custom, and it was like $10,000, and we're like, what? I didn't know.
Even the simplest thing, like it's just dropping plates into the nest, right? It's like 14,000. I was like, oh my god.
Yeah. Or device, go, $10,000.
Yeah.
I had the same feeling. I was like, I'm going to figure out how to do this myself.
Yep.
That's, I think a great story on the open source part. And I mean, do you have anything to add on how the significance to automation, in your opinion?
For open source?
Yeah.
Yeah, definitely. I think that I mean, for me, I want to write a scheduler. I would have never really done it if I had to write every driver. Founders or just people who are hackers, you can grab the driver that you want. You can contribute it to it. I mean, in my case, also supports ML star, and then recently somebody I forgot his name, I should know his name, but just wrote the Nimbus driver. I didn't do anything. Now I support Nimbus, and so it's just really useful that way. That now that's another thing for the company to support, and I didn't even really do anything. I might have to do like minor changes, but like the huge work of
the heavy lift is done.
Yeah,
that's great. Well, I hope that trend, and I think it will continue at a faster and faster pace for support of the different pieces of equipment. So how does Orca fit into the modern cloud native lab infrastructure, AWS?
Yeah, you mentioned that earlier, right? That's a good solution for some of these things that we encounter, is to make sure that we're in this environment where we can't really mess anything up physically.
Yeah, so it's part of the roadmap, I guess, of Cheshire Labs is you have Swarm AI, and that's like the integration layer with a REST API and the MCP. And that was kind of the vision of that thing I was writing at Sura for just getting events back. So just having that integration layer, and then on top of that, integrating Orca so that then you can have AI running your workflows, building your methods in there, and also having the ability to put through configurations of variables and stuff for wet testing and dry testing, different things like that. So it looks all like little pieces right now, but there's a roadmap with it all. So integrating Orca into the cloud just above Swarm so that it's using all the devices on that is kind of the plan.
Okay. Very cool. Yeah. So what kind of labs should be looking at open source schedulers? Everyone? No.
Yeah, I mean, anybody's welcome to use it. It's on GitHub, so they can.
But I mean, I'm sure there's some wheelhouse, sizing and things like that just makes a ton of sense out of the gate.
Startups that don't have funding, if they just want to test something real quick and they need something running real quick until they get a scheduler, just keep on using that scheduler. I guess anybody who's just interested in using it is welcome to use it. When I was building it, I had the SMC assay in my head, and then also like NGS runs that I was making sure that it would run for.
Okay. And any scenario you can think of right now where you should probably just go with something more traditional? This isn't the best for that. Not yet, at least, right? Well, I'm sure it's all going to get there. But
open tooling can make sense, and sometimes it cannot. Right?
Yeah, right. It's true.
If you need a GUI, there's no GUI on that, so you need just straight programming.
Who needs a GUI? No.
Yes. Until AI starts using GUIs, just skip them. But
just overhead.
Yeah. Recovery right now. I didn't write any recovery in it.
Okay.
Which is super important. I realize it's super important, but I was focused on if you could get things to run, like a few features, and I was like, recovery, we're going to have to put this one off. But hopefully,
you probably wanted some sleep.
Yes. Yeah, it'll be in there someday.
In all fairness, that's the last thing that happens in robot design too. Robot, integration, when you're designing a thing, it's like, all right, now I got to do air handling.
Yeah.
But
it's the first thing people ask about.
Oh, sure. Absolutely. Yeah. Right.
It's definitely super important.
How's your exception handling? What exception handling? There are no exceptions here. That's good. It's one of those things, and it comes with, I think, experience deploying the software and hearing feedback too. So you can kind of design that in a way that, somewhat matches the feedback you're getting too. Use that as an input. I think it's, it doesn't have to come right away. Just steering into our fourth segment, swarm automation, AI, and what comes next. So kind of looking towards the future. What does swarm automation actually mean in practice?
Give us the understanding that maybe some people don't know what that means.
With for Swarm AI, it's pretty much just the integration layer with a REST API and an MCP, so that you can drive it with Claude, or you can connect your devices and connect all of it with like custom software just via REST API. It's not going to run your entire complicated workflow or anything like that in a deterministic way, but you can run methods, like just an ad hoc method, like, just fill this plate real quick. And that way you're getting your integration back. Or, sorry, not your integration back, but you know how all your robots get integrated together, and then you can't do anything with them unless it's just the workflow that you're running. This way you can run like an ad hoc method on there.
Yeah, I saw a post that you had recently, actually, about Claude driving the robot, right? With
Brooks.
The Brooks.
That turned out that worked out pretty well, because
I shared it. I love it.
Yeah, we should link it in the show notes.
Yeah, that'd be great. It was, because I had come on site to do Orca, and then I was like, I'm working on Swarm AI on the other side of things. And then I think it was the final day that I was there, I was like, we'll just see if Swarm works, and it worked immediately with it. It worked out pretty well.
Yeah, no, it's a cool demo. Show how an API integration of a robot can be connected to like you said, an ad hoc request. Do this, do this very specific thing, and the robot just did it. And
I could figure out the teach points too. I was surprised about that one. That one ran first try also. That was
cool.
It worked out well.
Yeah, granularity in the control, right? Being able to adjust a millimeter here, a millimeter there, or whatever's part
Yeah.
of it.
So that's the other part. I mean, later on when you're building on, or when I'm building on top of it, having that that low level control of devices, the AI needs to know when to use it and when not to use it too, though. Because most of the time you just want to run a tested method or a tested workflow. But having the ability to really dig in, just like an automation engineer, of knowing when to start going into low level commands to troubleshoot stuff.
I've seen an apps engineer, work on a Hamilton and just instantly make the thing do hacked. It's turning a decapper at a certain rate that's not even in the the program or whatever, and it's amazing how much is available. But you definitely don't want to use it without some boundaries. You could just
Yes.
burn the motor out for whatever. It's a balance.
Yeah. Precise Flex has been really useful. I mean, it had good documentation and everything. I wasn't concerned at all with messing up anything. It would just hit something and it was just fine. Like
bounce off.
Yeah.
Yep. That was the intention. So where would you say AI helps today and where it creates risk?
I feel like we're pretty early on AI with lab automation, so it's hard for me to say fully where it helps. I think it's going to be helpful in a lot of areas, especially doing low-level things like liquid classes or keeping track of all the variables that automation engineers kind of lose track of. I think that we're also have AI now and kind of losing sight of like our software layer still needs a lot of fixing, and everybody's focused on AI. And if we keep on compiling or piling AI up on top of the software we have, I think we would do a lot better to make changes to the software we have with AI on top. It'll be a lot more powerful.
Yeah, that makes sense.
So where do you see the risk, though, in that viewpoint where you're trying to now use AI to make the software we have better? Does that risk anything in terms of learning, moving forward, growing, actually building things that we can carry forth into the next innovation?
Like you mean automation engineers not quite learning as much, or like not knowing the software behind things as much?
Maybe it could be that.
Yeah.
We have a whole AI series on how we can actually leverage AI to do faster research, to do different simulations for molecular docking, to help even start protocols, right? So there's ways that it can advance our own skill set, but if we only depend on that, there's risks there as well, right?
Yeah. It's hard to say. I think with each new technology that kind of comes out, people have similar concerns. Like, C++ comes out, oh, they're not going to know assembly language and things like that. I think some things go away and others kind of take their spot. Within lab automation, I guess one of my concerns is that we're going to have AI building out workflows, and when we go to troubleshoot it, we have a little bit less context of even what the workflow looks like that we're troubleshooting it, as to what the problem is that we're troubleshooting, or what variables are in there that are set that could be causing the problems. Because I think a lot of vendor devices have their little oddities of what you can and can't do in them.
It's a feature, not a bug.
Yeah.
Yeah, and I think that's something that this effort, the process you're going through of creating this solution with the Orca, I think that actually there's a lot of gravity to it, for even a small organization, because as you get adoption, that will drive innovation within the vendor network, right? To optimize, because you're right, there's a lot of variability between different devices. Like one lets you do this, one you kind of bouncing off the walls. Each one is its own thing. And when you add AI to it, which let's say you want to, depending on, it's almost like you need a gauge. What's this AI readiness meter? I'm just coming up with this right now. For example, the robot driver, right? Very AI ready to go, because you can plug it into something that you can give instructions, very low risk of destroying anything. Boom. I could even say robot go up 10 millimeters, whatever. That's direct. But a lot of devices, nope. There's only one command that has all these things tied to it. I can't sit there and do number 3 of the 5 things that command does. That piece of it, I think, is part of like what I've seen with the Star. You said the Nimbus now, right? I mean, now you've got pretty direct control of that device without having to go through anything. Now you have to be on your own guardrails, but still, there's the facilities are there. It's kind of open-ended, right? At the end of the day, it's like, I'm not sure what I'm going to ask you to do next, but it's coming, you know?
Yeah. I think having that type of control will be most useful for AI, because then you can grab things like pipette sensors and stuff and start having it do the troubleshooting for you to figure out what's going wrong. So I think you really want AI to have access to the sensors also.
Yeah, it's exactly. It goes both directions. At the end of the day, you're getting more feedback out of the device. We were talking about that recently, in a meeting about the camera system, right? The camera system is helping you close the loop on, is the plate in the right position? This is also, all the instruments have all kinds of feedback that they can give to see if you're on the right path and verify and validate and all those things. So
yeah, pulling the camera system in there would be awesome too. I haven't started looking at that, but putting that in the loop of AI, like, a
lot of things on the roadmap for the camera systems, because they've already even like the PTZ cameras with their detection and the recording and playback, the fact that you can create like a cloud image, where you can just sort of pan around it by taking all the images and putting them together these days. I've seen them in some of the lab deployments. I'm like, that's awesome, because like your forensic information is just huge 24/7.
Awesome.
You could figure out what went wrong at 2:00 in the morning or whatever it was. Just putting that on the end of the robot's another level. But well, really great discussion. I think, at the end of the day, like, if AI is working with an instrument, there's got to be a readiness factor, right? Otherwise, it's just you've got the blow up factor. Like, that didn't work very well, all right, sir, we're going to go off and create a standard called the AI readiness factor.
I mean, with all these discussions across all the different guests that we've had, it's always something I think about, right? Because as we move AI into actual like systems and hardware and things that are being controlled, you have to start thinking about guardrails and how do we make sure that at the end of the day, AI is just not turning an instrument on and suddenly it's out of control. Like, there has to be a lot of structure. And I think that's another opportunity for lab automation when we didn't take the opportunity before to create standards, to really create standards around this new technology, right?
So in the case of Swarm AI, there's not too many guardrails with things. You get the MCP and the driver kind of has the guardrails. And with Orca,
that's good distinction.
Once I get Orca integrated into it, then you start having more guardrails because the methods and workflows are kind of defined. And so that starts putting down the guardrails, and then put the GUI on top and you have the human in the loop for double checking things. But yeah, I mean, Swarm AI is it's early, it's a little bit of Wild West a little bit. So, but there's enough guardrails in like the precise flex that it's not going to ruin anything. And
that's good about Swarm AI, but it's just always good when you're talking about AI in general, right? Like, what is this going to balloon into? Because eventually, right, these systems do end up connecting and somebody just decides to like run everything without thinking of that structure.
Yeah, even having Claude jumping on the command line and I see RM-RF on there with it deleting something, I gotta pause for a minute and be like, what are you deleting? Yeah.
I always have to tell it, you are my lab assistant. You will ask me before you do things.
Yes.
Trust, but verify Swarm. Yeah. Well, it's, it's an evolution, right? I mean, a lot of these software stacks that are running at the very low level and the device level were written 20 years ago, and there's some things that need to be undone, redone, and reworked. It's part of the process. And eventually some board will no longer be manufactured and they will have to redo the entire board. Then that means it's just all new software, new real-time OS or whatever device it is that they're running it. And then ta-da, now we can run 1,000 threads at the same time with our CPU instead of 2. We found it like when we re-architected to went from PowerPC to ARM, which is like a 25-year jump in time, and you realize, oh, this ARM, I mean, even the lowest end model can run, circles around 1,000 PowerPCs. So, well, anyway, really great discussion, Michael, and thank you so much for coming on. We're not done yet. We do have a little of a little closer. If you were designing a lab from scratch today, what's one architectural decision you would not compromise on?
Dun dun dun.
I'd really try and make small methods, and I would probably put an integration layer on things to just integrate it all together, because you're going to have to connect all those devices. Yeah, it's just going to be easier to connect if they're all connected together, really. But yes, small methods I think is useful, and then having like a scheduler on there to kind of make the decisions of which one to run.
I love our Automation in the Wild series because it's always people who have actually and are actually doing the work. So you get very straightforward answers with deep, heavy sighs because they've been there in the trenches,
Yes.
Yeah, and I want to I want to have you on again, later down the road, and kind of, check in on the evolution of what you're working on. And right now we'll step into I have a pick of the week. So even if nobody else has a pick of the week, I'll still.
I do have a pick of the week, but I think he might, because Mike, you talked about Claude a lot, and I'm wondering if that's your, AI of choice. Some people like ChatGPT, some people like other things, but
no,
Claude
it's
is
Claude
like Code.
Yeah, all day. I was using ChatGPT. I usually use that for like writing an email, but Claude Code, all I do is just VS Code with a Claude Code extension, and then I just put it on edit automatically and just let it run.
Yeah.
But it's just giving it a little chunks of what to do. I read somebody made a suggestion when they're building out software to tell it to interview you about what you want it to build, and then I just tell it to kind of interview me after giving it a summary and to any assumptions to include in that interview. It works pretty well.
Oh, I'd love to get your prompts for it.
Yeah. I mean, they're so powerful. They can figure things out pretty well, and just how Claude Code can go through and grab the context of the code. Yeah, it's crazy where these things are. And I really wasn't even going to do AI on lab automation at all, and then I started using Claude Code, and I was like, I'm wrong. I got to start pivoting because I've completely underestimated what's going on here.
That's awesome. See, we got a pick of the week out of you anyway.
Pick of the week, yeah. So it happened. Well, right on. Well, my pick of the week is for folks, I mean, you can't miss it in some of the social media feeds. They always talking about the Flipper Zero, right? Well, I got the video game module. So it's nice. Like basically on the Flipper, you can add this on, and it's a Raspberry Pi essentially. So it's a separate microprocessor from the usual Flipper. And it's just the Flipper Zero. But I just got this, and I've already started playing with it a little bit. Very cool. It's HDMI on the top, so this is like you're literally using this as your game controller. You plug it into the electrical interface on the top, which is a GPIO base, old GPIO standard, and you've now got a video game thing, so you can.
Is this one of those things that you found in your storage of tech?
No, I ordered this. This is not out of the. That's right, Mike's box of gadgets. Because in the past I've just randomly pulled that stuff. It's like, pair of headphones I haven't used in 20 years. Oh, well, this is my pick of the week. Anyway.
I've seen those. Then you can turn on the game at the bar anytime you want.
Yeah.
Yeah, exactly. It's like, I really want to watch the Sharks game or whatever it is. And they're like,
no,
we're watching the Patriots. No, we're watching Sharks. Anyway, yeah, that's my pick of the week. So, yeah, for listeners, little wrap up here with Michael Salmi. If you'd like to reach him, you can check him out, Michael Salmi, Salmi, on LinkedIn, and check out what's going on with Orca on GitHub as well. Yeah. What's the website, website to reach at?
CheshireLabs.io.
.io. Got it. Okay, perfect. Well, awesome, Michael. Thank you so much for coming on, and we really enjoyed the discussion today. I'm super excited. Like I said, I mean it. I want to have you back on and check in with you and see how things are going on how this is evolving, and I'm looking forward to seeing it more in the field, controlling PF400s and you name it, any of the robot series and the Precise Flex, and getting it done. So for the moment, this brew is brewed. We'll see you next time.
Thanks, y'all.
Take care. Thank you for joining us on the Helical Brew. We're glad to have you with us. For more episodes, please visit our website at helicalbrew.com. That's helicalbrew.com.